So we want to compare three different equations, and we have the data for them. This time we're doing the chimney climb. We'll have the time and the velocity, and here we have the price of the croissant, and here we have the gross profit at that price. And here we have age, and then based on age, we have the number of hours of sleep that we have per day. So in comparing these, we can determine the function we want to model the situation by comparing this first to confirm, okay, this is consistent. It's always add one, add one, add one. Now we can compare the other side. We say, okay, what changed here? This is what happened, 12 to 6, and then 6 to 3, and 3 to 1.5. What's happening? This is times 1/2 all the way down. So that would be modeled with an exponential function. The velocity is equal to, in this case, the equation is velocity is equal to 12 times 1/2 raised to the t. So for this second situation, we also have the same thing. We increase this plus 10, all the way down, always plus 10. Now we can compare these, and when we compare them, what we'll find that there's no consistent thing to multiply by. So let's compare what happens, the difference between this and this. This is plus 215. This would be plus 165.
This plus 115. This plus 65. Minus 335. This would be minus 85.
So that doesn't seem like much of a pattern, but watch what happens with the second one. Here, 215 to 165. What happens here? This is minus 50. This is also minus 50. And this one, and this one, and this one. So it's not the difference of the result, which is this, but it's the difference of the difference is consistent and constant. That would be quadratic. Now, it's not important if this is a negative or a positive. It does tell you something, but in any case, the difference of the difference is always the same. And we can model that situation with the gross is equal to, in this scenario, these numbers would give you this equation. With the gross based on the price, P, of this equation. So in this last scenario, the age goes from 0 to 3, that's plus 3. 3 to 6, that's also plus 3. 3 to 6 to 9, 9 to 12, all plus 3. So we can now compare these. So if we compare the right-hand side, the result, the sleep hours, what happens to these? It's minus 2. And in here, also minus 2. All the way down is subtract 2. So that, if this has a constant change, along with this has a constant change, that would be modeled with a linear equation. Sleep, L, is equal to, for this data set, negative 2/3 A plus 20. Now, if we extrapolate that, or even if we just take one more year, do you think all teenagers get 10 hours of sleep? Sometimes 20, sometimes 2. If you also take this to an extreme and say, let's continue this, then 30-year-olds would have no sleep at all.